All right, we're here with period 1 to talk about solving polynomial functions for their zeros or roots. And we're going to be using the rational root theorem, which is up on your first slide here, the rational root theorem to find these zeros and roots. So let's look at a problem. Please read this problem for me, Bashir. Excellent. When I read that problem, and when I say I mean Bashir, thank you. When Bashir read that problem, what should be the first thought that you have when you read that polynomial? The first thing you should see. The 4. The 4. The 4 is right. Because when I see that 4 as the highest exponent, I should have 4 roots.
Is that 4 answers? That's
4 answers. All right, so you should have 4 answers at the end of this problem when we're all done. Now, because we cannot factor this, do you see how they all don't have something I can factor out? They have no common factor besides 1. And you don't know how to factor a 5-term polynomial, all right? Then we must use something called the rational root theorem. The rational root theorem says that if you look at your constant and write down plus or minus the factors of that constant, there will be rational roots in those numbers for this polynomial. So what are some factors of 36?
4 and 9.
6 times 6, 4 and 9.
12 times 3.
12 times 3.
9 times 4.
We said that, 4 and 9, 9 times 4.
1 and 36.
1 and 36. I think there's one more pair we haven't said yet. 2 and 3 and 12. 2 and 18. Write that plus or minus 1. Plus or minus 2, you should write this down. Plus or minus 3, plus or minus 4. Oh yes, Caesar, it's coming back. Plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36. Now, so what you'll see is that technically the rational root theorem says to take all these numbers and divide by plus or minus the leading coefficient. But what is the leading coefficient in this problem?
1.
It's 1. So all these numbers divided by plus or minus 1 is just these numbers. All right? So if we were doing a problem that had a 2 here, I would have all of these numbers here as well, and the numbers divided by 2 as well. So I'd have 3 halves, 9 halves, and that's it. Those are the extra ones I would have, because all the other ones divide to numbers I already have. All right, so you just have more to try. Now, what you're going to see in doing this is that you're always going to start with the same number. The number 1. And how do I see if 1 is a root?
You plug it in.
How am I going to plug it in? Because that's what I'm going to do. I'm going to plug it in. I'm going to plug it in with this thing called, I don't know if you heard this before, synthetic division.
Oh, yeah.
What? All right. What are my coefficients from the problem? 1, negative 3, 5, negative 27, negative 36. Yay. You should. We did it yesterday.
No.
I'm messing with you, Lexi. All right.
Bring down the 1.
Bring down. Well, before we get started, Dino, let me just pause for a second. You're good. We're going to bring down the 1. I got you. What do I want at the end?
0.
I want 0. Okay? If I don't get 0, then I just go to the next one. All right? So let's hope. Oh, there it is. Some other people know. Oh my gosh, I've done this before. Let's hope. What? What's the easier way? There's not another option until you get 1. Once you get 1, I'll show you what you can do that's easier. But you got to get 1 first, Caesar. Well, if it's not a 0, yeah, we'll do negative 1. All right, here we go. Yes, Tina. I go to the next number, negative 1. I'm literally going to go through these numbers until I get a root. Hopefully it'll happen soon. Here we go. Bring down the 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Heidi, this is what we did yesterday. Negative 2 times 1 is negative 2. 5 plus negative 2 is 3. 3 times 1 is Negative 27 plus 3 is? 24. Negative 24 times 1 is? And sadly, this is not 0. So this would be not a root. Sad. Not a root. So I'm literally going to do the same thing. Yes. But with negative, I need a root.
Well, you try all.
I try, hopefully on all of them, until I get a root. Please, God, let it be this one. Please, God of math, let it be done.
It is.
Let thy will be done in math. 1 comes down. 1 times negative 1 is? Negative 3 plus negative 1 is? Negative 4 times negative 1 is? 4. 5 times 4 is? 9. What are 9 times negative 1 is that?
Negative 9.
That's negative 36, which is positive 36, which is? Woo!
Yeah.
Just hurt my knee a bit.
Wait, is that negative 27, negative 17, or negative 9?
So, this is a root. Now, once you get a root, I want you guys to go to the next slide. So the next slide is blank. All right? So the next slide is blank. Here's what you're going to write there. If you get a root, you're going to write your first factor of this polynomial by thinking yesterday, how did I put the number in the corner? What did I think about when I put the number in the corner? X minus a, right? And I always had to think opposite. So when I see negative 1 is a root, when I write down my first factor, I'm going to write down x plus 1. Because you think opposite. All right, another way to think of it is, what number makes this 0? Negative 1. Now, to write the rest of it, I need these coefficients. If we started with x to the 4th power, this is going to start 1x cubed. So x cubed. So I'm using the numbers from the last one, yes? So I'm using x cubed minus 4x squared plus 9x minus 36. And you'll notice no remainder. That's the whole point. There is no remainder. So let's see if I remember. Minus 4x squared. Is it plus 9x? Thank you. Is it minus 36? Excellent. Now here is probably one of one of those moments where students become robots. Like you start to learn the process, what the teacher is teaching. You get it, you do all the work. Awesome, yay. But you don't actually think about what you just wrote. So I want you to look at what you just wrote. Okay? What is x times x cubed? X to the 4th power. What is x times negative 4x squared? Negative 4x cubed. And if you did 1 times x cubed, you'd get x cubed. Negative 4x cubed plus 1x cubed is negative 3x cubed. I'm showing you, Shiloh, that even though this looks like it's gone, it's still here. It's just beginning to be factored. This is still the same problem we started with that Bashir read for us. But we've begun to factor, to break it down. All right? Now, Caesar's brain thought, wait, I thought you taught me a couple years ago how to do this a little quicker, right? So what I usually tell students is, you could keep going. What's the next number that I could use? 2. But I would use these coefficients now. I already have a factor from my first root. So if I wanted to keep going, I would use 1, negative 4, 9, and negative 36. I don't recommend that. I don't recommend that because you should be able to factor this one with factor by grouping. Ooh. What do x cubed and minus 4x squared have in common? X squared. What's left after I factor that out? Nope. X minus 4. What do 9x and negative 36 have in common? 9. And you didn't say positive or negative, right, Pablo? So you need to write positive 9 when you pull it out. So what's left? X minus 4. Now, ultimately, these in the parentheses have to be the same. Those have to be the same. And you can always check to make sure you've done this right. What's x squared times x? X cubed. X squared times negative 4. 9 times x. 9 times negative 4. So it's still there, just we're factoring it. They have a factor in common, x minus 4, so bring that down. What did I pull out of each of these? What did I pull out of each of these? X squared plus 9. And then do you remember our very first factor? X plus 1. We have now fully factored the polynomial that Bashir read for us. It is fully factored. And once it's fully factored, that means I can solve for the roots. Each of these factors will be set equal to 0.
But that only gives 3.
And you know, that's a valid question. There's only 3 factors. I wonder how we're going to get 4. The x squared is going to give us 2. No, your classmates are right. All right, so I think we're good on the left one, because that was our very first root. Yes, negative 1 was our very first root. What about the one on the far right? Positive 4. So we've got 2 so far. But the one in the middle is a little trickier. Move that 9 over. Yes, please do that. Move the 9 over. Yes, everybody good? Became negative. How do you get rid of that square? Square root of it. You got to do it to both sides. Oh my goodness, and you've got to do plus or minus. But oh my goodness, we just took the square root of a negative number. You cannot do that. No, you can't do that. Okay, probably, worried. So it's plus or minus. I think Gilberto's got something for us. What? It needs, not an I thing, it needs an I. For the imaginary numbers. So we have 2 real roots. Negative 1 and 4 are called real roots. Do you remember what these are called when they have the I? Imaginary is right, but there's another word we use when they have imaginary. There's another word, starts with a C.
Creativity.
Charlotte, that's not very nice. Right, we got that on recording now.
You're very smart.
Okay. They're called complex roots. Complex roots, because there's a real number, 0, plus or minus 3i, which is an imaginary number. Real plus or minus an imaginary number is called a complex number, because it has both. Oh my gosh, that's algebra, right? Good times. Now, are there any questions about how we found these 4 roots? Because you're about to get up and do 2 of these by yourself.
Oh my God.
2 of them. There's 4 roots. I know it's hard to see. There's 1, 2, positive 3i, and negative 3i. So there's a total of 4. 4 roots. That's what we wanted? We wanted 4 roots. Yes, Tina. Of course. All right, so I can stop this and have us stand up and try?
Yep.